Hi all, welcome back. So in today's video we are going to talk about APB signals. So in the previous session we have already talked about APB protocol introduction and also some AMBA architecture and all. And also we have seen what are the signals that are present in APB and what are its key features and all. Okay, so in today's session, we are going to talk about APB signals. While you are learning about APB protocol, you should be thoroughly understanding the three concepts which are APB signals, APB state diagram, and as well as the timing diagrams. Okay, if you understand thoroughly about these three concepts, then you are sorted out while you are learning about APB. Okay, so there are certain signals in APB which are of single bit wide, and there are certain signals which are of 32 bit wide, or some are of 4 bit wide. So we'll be talking about all these signals description, and also we'll be discussing in deep about all these signals in today's session. Okay, but before going to that, if you are new to my channel, please consider subscribing my channel and hit on the notification bell also follow me on all my social media handles. Okay, now coming to the signals. So okay, we'll be discussing all the signals one by one. So this is my APB master and this is my APB slave. Okay, so as you already know what will be the master and what will be the slave. So let us consider this is my APB master and this is my APB slave. Okay, so for the one thing you have to remember is that you can connect any number of slaves to your master. It can't be only one. For example, if you are taking your laptop or PC, you will be connecting various peripheral devices at once. Is it or not? Okay, you will be connecting keyboard, and you will be connecting the mouse, as well as you will be connecting the printer. So in this way you will be connecting multiple devices for your single laptop. Is it or not? In this way you can have multiple number of slaves. Okay, there no it is not said that you should have only one master and one slave. Okay, master can have any number of slaves. Priya, yes, you should remember first, but as for now we are just talking for one master and one slave. Okay, so for this APB master and slave, the first two important signals are the P clock and P reset N. Okay, so the P clock and P reset N are nothing but these are the input signals. Okay, so as I already told you in the previous session, the clock and reset are always the input signals. Okay, so in APB, the clock will be in that means whenever the transfer is being done in the APB, it is done only on the rising edge of the clock or pause edge of the clock. So clock is always at the rising edge when it comes to APB transfer. Okay, similarly reset, as you already know what is the meaning of reset. That means whenever you are giving reset, then all the values will be resetted to their original values or their some default values. Okay, so in APB the reset is always the active low asynchronous reset. Okay, so that means APB transfer will take place only when the reset is active low. Okay, so this is about the reset and clock. So the clock should be always in the rising edge and the reset should always be active low. So when these two cases occur only, then only the transfer or transaction takes place from master to slave or from slave to master. Okay, so this is about the P clock and P reset signals. Okay, now coming to the signals one by one. So the first signal is P select. Okay, basically whenever you see in any protocol or else if something, this P select is indicated as P select X or P select N, or p select itself. So basically, what is the meaning of this x or n or just p select is nothing but, for example, here if you are taking the protocol here, I'm using only one master and one slave. So since I'm opting for only one slave, I'll just go for p select itself. Okay, but as I told you in the previously, that you can have any number of slaves. Okay, so for example, if you are connecting some four number of slaves, then the master should select to transfer which slave it should transfer the data. Is it or not? Because it can't transfer the data for all the slaves at a time. Is it or not? So it should consider, it should select which slave to be selected in order to transfer the data. So in such cases, you will be opting for p select x. Okay, here the x denotes what slave it is going to activate, like what slave it is going to select. Okay, so for example, if you are selecting p select 1, that means the first slave. For example, if there are four slaves here named 1, 2, 3, and 4, so p select 1 means the first slave is selected. Similarly, if p select 2, then second slave is connected. P select 3, select third slave is selected. P select 4 means fourth slave is selected. So in this way, based on the x value, okay, the selection of the slave is being done. Clear? So that is what p select x. P select x, or some in some protocols or in something, you will be seeing it as p select n. P select n or p select x. So x denotes this particular thing. Which slave to be selected is denoted by this x. If there is only one slave and one master, then that is just p select without any x. Got my point? This is about the p select. So in order to select the slave, this option, this particular signal is used. Okay, the slave, we'll call this a slave selection signal. Okay, when you are selecting the slave, you will be using this p select signal, right? And also, one important thing about this p select signal or APB is that, as in the previous session I already told you that APB is of 32-bit wide. Okay, so whenever you are connecting the slaves, you should remember that the slaves size shouldn't exceed this particular 32-bit wide. Okay, that means how many slaves we are going to select, we shouldn't exceed the width of 32-bit wide while we are connecting the slaves for APB. Okay, you have to first remember that, right? This is about the p select signal, and this p select is of single bit wide. Okay, and then, so in this way, for example, if you are selecting four signals, then it will be p select 1. Similarly, four things like p select 1, p select 2, p select 3, p select 4. In this way, four p selects. Okay, so this is about the p select signal. And then the next thing is p enable. Okay. Now, what is this p enable signal? From the name itself, you could say that enable is nothing but we are sending the request to the slave. That means the master is sending the request to the slave whether it is being ready for taking or reading or writing the transactions. That means what can the master do to the slave? It can either read some information from the slave, or it can write something into the slave. So in order to do this read and write transfers, the slave has to be enabled. That means it has to be ready in order to receive it. Is it or not? So that request, like whether in order to receive, whether it is ready to take the data or send the data, so that will be checked by using this p enable signal. Okay, so basically p enable is for that action. And then the next, and also this p enable is also single bit wide. And then the next one is p address. So basically when it comes to p address, it is of 32-bit wide. So what is this p address? So basically every slave, or every, for example, if you are considering four slaves or a single slave, it will be having some address locations, because without address locations you can't read or write the data. Is it or not? Right? So if you want to send something, okay, for example, if you are sending some gift to your particular person, you need to, in order to send it, then you need to know their address. Is it or not? Similarly, in order for the master to send something, to send some information to the particular slave, it has to know its address. Okay, so that is why p address is very important here. Okay, it is just the memory locations. Okay, if we are having four things, then it will be having four types of memory locations. So everything is stored in this p address. Okay, and this p address is of 32-bit wide in APB. Right? So now after p address, what are the things? Next is the next signal is p write. Okay, so basically, what is this p write signal? So Prite is just like a control signal, we can say. Basically, whenever you it depends. Pwrite, whether when you want to read the data from slave or whether you want to write the data into the slave. So basically, these are the two operations that will be happening, either read or write. Is it or not? So whether to do the read transfer first or whether to do the write transfer first, it depends on p-write signal. That means if p-write equal to 1, then write transfer takes place, and if p-write equal to 0, then read transfer takes place. Okay, so depending upon whether the p-write is 1 or 0, the transferring takes place from master to slave. Okay, that is p-write signal. So basically it is the control signal. Why? Because the transferring of read and write will be done based on this signal itself. So basically we'll call it as a p-write as a control signal here. Okay, and then coming to after p-write signal is 1 or 0, then you can either read or write data. Is it or not? So the next one is read and write data. Read data or write data, both are not same. Okay, you are having two different signals. Okay, either pr data or PW data. Okay, so both these are also of 32-bit wide. Why? Because since address is 32-bit wide, obviously since there are 32 memory locations, you can obviously read from 32 memory locations or you can write into 32 memory locations. Is it or not? So that is why PWrite and PW data and PR data are also 32-bit wide. Now what does this PRead data and PWrite data do? Basically, when you want to read something from the slave, so basically what is this reading and writing means? Okay, when you want to transfer the data, when the master want to transfer the data into the slave, that is called writing. Okay, so when the master want to read something from the slave, then take something from the slave, then it is called as reading. Okay, so PR data means P read data. That means when this will happen, it will be happening from APB slave to APB master. That means the signal will be in this format. Okay, and when you want to transfer the data from master to slave, it will be in this way. Okay, so both are of 32-bit wide. So write data means write transfer takes place. Okay, read data means the read transfer takes place. PR data and PW data, right? So now these are some basic signals, like from starting APB to the until now what we are using, the latest version is PV 2.0. So until these are the all these are the signals that are common in all these particular APB. Now, as we discussed in yesterday's session, in version 1.0 and in version 2.0, certain signals are being introduced. So now coming to those signals. What are those signals? One is P ready, okay, and then P slave error, okay, and then P strobe as well as P protect. So these are the certain signals which were introduced. Now coming to this particular signals, here the P ready is of single bit wide, and then the P slave error is also of single bit wide. When it comes to P strobe, it is of 4-bit wide. and protection is of 3-bit wide. You have to remember the signals. Okay, so the width of the signals are also mandatory, because while you are writing the code and verifying the code, the signals width is you should consider that. So that is why you should remember the width of the signals. Okay, so these are the 4 signals. We'll be talking about them also, don't worry about that. Okay, so these are the 4 extra signals that were introduced in version 1.0 and version 2.0. Okay, so since we have already talked about the signal, so just let us have a quick review. So p clock is nothing but system clock will be directly connected to this particular p clock. So the p clock will always be on the rising edge of the clock. Okay, that means the transfer takes place on the rising edge of the clock. And then p reset, here in APB the reset is active low asynchronous reset. That means when the clock is on the rising edge and the reset is active low, then only the transfer takes place. Okay, now coming to P select. We have already talked about this. In order to select the slave signal, we are using this particular signal. Okay, there will be only one P select signal for each slave connected to master, because at a time the master can transfer only one slave. So that is why you have to select which slave the master have to transfer the information, or from which slave the master have to read the data. So that is why it is necessary to select the slave if you are having more than one slaves. If there is one slave, there is no need of such confusion here. Okay, so if you say master connected n number of slaves, so p select 1, p select 2, p select 3, and so on up to p select 1. Okay, maximum number of signals present in the system. Now coming to p enable, so indicates the second and subsequent cycles of transfer. That means that I told you, p, if only when p enable is 1, then only the access for the transfer takes place. That means only when you are sending the request to the slave that you are going to transfer something, then only the slave will be activated, and then only the transfer takes place. Is it or not? Right? So in this way, p enable is nothing but you are telling the slave that, or you are telling the slave that you are sending, the master is telling the slave that it is going to send something, so that the slave is ready to accept it. Okay, so that is about this p enable signal. When you are p enabling, that means when you are asserting and deasserting are the two technical words that you will see here. Asserting is nothing but you are making it active. That means you are giving it the value of either 1 or mostly 1 here. Okay, that means only when p enable equal to 1, then only the access, that means the transfer of data takes place. When p enable is 0, then that means the transfer is not going to take place, because you are not giving any information to the slave. Then how can you expect the slave to be ready to take the information? Is it or not? So in this way the p enable is important in case of APB, right? And then coming to p address, address is nothing but the locations, the how many memory locations are present for APB. They are 32-bit wide. Okay, address from master to slave, and the width is of 32-bit wide. Okay, and then coming to p write. Okay, indicates write transfer to takes place when write is high and read when it is low. Okay, basically when p write is high, that means p write is 1, then write transfer takes place. When p write is 0, then you can consider that the read transfer is taking place. Okay, and then pw data. If you see here, p write is of single bit, p address is of 32-bit, pw data is of 32-bit, pr data is also of 32-bit. Okay, now okay, so these are the two signals. Since we have already talked about this p write data and p read data, so basically write data bus from master to slave. Okay, that means whenever you want to write the data from master to slave, then it is write. Okay, from master to slave, then it is write. And reading is how it will be done. Reading will be done from slave to master. Okay, you have to remember this. Writing will be done from master to slave. Reading will be done from slave to master. Okay, so this read and both this read and write are also 32-bit wide. Okay, then coming to the four signals that have already talked about, which is P ready. Okay, so what is this P ready? So, for example, P ready is nothing but whenever it indicates whether the transaction is being complete or not. Okay, so basically, what happens means, okay, you will be sending the information from master. The master will be sending the information to the slave. Is it or not? Okay, as soon as you are giving the P enable, that means the slave. That means you send the request from master to slave that the you are sending some data, fine. So the master is sending the information, sending some data to the slave. So now the slave is accepting the particular data. Now, after completing of that particular data processing only, then only the master should give another information or another data, another packet of data. So in this way, the master, in order to make the master know whether it is ready to take another packet of data or another transaction, what will the slave do? It will give the master some response by using the P ready signal. So now when P ready is 1, that means that the before transaction the master has sent to the slave is completed, and now it is ready to take another transaction. That means it is ready to take another packet of data. Okay, so this indicates the P ready and P slave error are basically called as response signals. So why are they called response signal? Means for the action that the master is doing, that means for the packet of data or for the transaction that the master is sending from master to slave, it is responding to that. Okay, the slave is responding that yes, I am ready now, you can send me another packet of data, because the packet of data that you have sent me, I have already processed it, and you can send me another group of data or another packet of data. It is responding it. Okay, until and unless if P ready is 0, then that means the slave is not ready to accept another packet of data. That means it is processing the previous data, it is not ready to accept another packet of data. So then what happens? The master have to wait. Okay, there we will see this wait states. Okay, so the master will be waiting until the slave is ready. That means until P ready equal to 1, the master have to wait, and then it have to send the data after P ready is 1 to the slave. Clear? So this is about P ready signal. Okay, so basically when anyone say P ready equal to 1 means the slave is ready to accept the information. That means already the slave has accepted one packet of data and it is processing it, and now it is busy in processing that. So it is if period equal to 1 means it has already processed the data and it will be accepting another packet of data. That is the meaning of period equal to 1. Okay, and then period equal to 0 means the slave is busy in processing the previous packet of data, so it needs some time in order to process the next packet of data. Okay, in simple words I'm just telling without any technical uses so that it will be easily understood for you. So this is about P-ready signal. Okay, and then coming to Pslverr. So basically, transfer transactions is being done. So if there is any error in that, that means when there is if the transaction is not received properly, or if the slave is of low power. Okay, so basically, slave error can be of due to many reasons, like for example, if you are taking some 4 to 5 number of slaves, okay, and the slave that you have chosen may not be present in that particular thing. Okay, so in such cases you will be seeing the slave error. Or if the for example, if the slave is of power down, or if the transaction that you have sent is that means if the transaction is you send is not completely done, so in such cases you will be finding the slave error. Okay, this is also response signal, because the slave will be responding to the signal that is sent by the master. Okay, that means the transaction that is sent by the master, if it is not completely received, or if there is any error while receiving it, so in such cases it will be responding that there is this slave error. Okay, basically, so by this we can say that by getting the slave error, it indicates the success or failure of transfer. Okay, so if p slave error equal to 1, that means there is error. That means this indicates the failure of transaction. If p slave error is low, that means if p slave error is 0, that means there is no error, so the transaction is successful. Okay, so this is about the p slave error. And also here there is one thing that you should remember about these two signals. That is what means, if period equal to 1, okay, if period equal to 1, then slave error is 0. Why? Because if period equal to 1 means this indicates that the before transaction is successful and now it is ready to take another transaction or another data. Is it or not? That means when period equal to 1, then that indicates the transaction is successful. If the transaction is successful, then obviously the p-slave error should be 0. If p ready equal to 0, that means if the slave is not ready, then you may expect that it is not sure that p slave error should be uh, 0, p slave error should be 1, but if p ready is not 0, then you may expect that there may be some error and slave error can be 1. But here this one is compulsion. That means if period equal to 1, then obviously the p slave error at that point should be 0 itself. You should remember this. Okay, this is about the period and p slave error. And the remaining two signals are Pstrb and P protection. So Pstrb signal. Basically, the strobe signal is only present in data width. Okay, if data width is greater than 8. Basically, you'll find this p-strobe signal only for write data. You don't use this p-strobe signal for read data. You should first remember that. Okay, p-strobe signal is only for p write data, but not for p read data. So whenever you are writing the data, okay, so if that data that you are writing, writing from master to slave, if you are writing some data, and if that data is greater than 8, then in such cases you will be using this p-stop signal. Okay, so what is the use of this p-stop signal? Basically, here, okay, let me show you it in a pictorial representation so that it will be easily understood for you. Okay, so basically you all know that the APB signal is of 32-bit wide. Okay, the read data is of 32-bit wide. You already know it. Okay, so this 32-bit wide data is divided into four strobes. Okay, that is from 0 to 7, and then from 18 to 15, from 16 to 23, from 24 to 32. In this way, it is divided into four lanes. Okay, these are called as byte lanes basically. Okay, if the width is greater than 8, that is why, that means if the width is greater than 8, then this p stop signal will be inactive. That means, sorry, the p stop signal will be active, inactive state. So basically, how are we going to divide? This p stop signal will be calculated by using this particular formula, like 8n plus 7 is to 8n. Basically, when you want to like denote this p stop signal, you will be denoting with this formula. Why? Because for example, if n equal to 0, that means this is from 0 to 7. That means if this p stop signal is 0, p strobe of 0 means it is from 0 to 7. Similarly, p strobe of 1 means it is from 8 to 15. Okay, p strobe of 2 means It is for Prot data of bits from 16 to 32. Similarly, Pstrb of 3 means that indicates the Prot data is from 21 to 32 bits. Okay, so basically Pstrb is indicated in this way. So, for example, how do we use this Pstrb means? For example, if you are seeing it as 0, 1, 1, 1, if our Pstrb signal, since it is of, as I already told you, it is a 4-bit wide. If this particular signal is 0, 1, 1, 1, then this indicates that since it is 1, 1, 1, so that indicates that we are using only the 24 bits for transferring the data. Okay, so based on the Pstrb signal, you can estimate how much amount of data is being transferred. Okay, so it is only for writing, not for reading. So when you are writing the data, in order to know how much amount of width of data you are taking, because if Pstrb is, for example, if it is 0, 0, 1, 1, then that means it is using only 15-bit data to transfer. Okay, similarly, if it is 0001, then it is using only 0 to 8 bits. Okay, so in this way, based on the Pstrb value width, you can estimate how much amount of data is being transferred from master to slave, how much amount of data is being returned from master to slave. Okay, this is about Pstrb. Now, as I told you, Pstrb is only for P write data. Okay, so that is why when the reading transfer takes place, that means when PR data is being done, then this Pstrb is 0. Okay, the Pstrb values will be 0. If the Pstrb values are all 0, then you should understand that the retransfer is taking place. Okay, instead of write transfer, the retransfer is being done when Pstrb is all zeros. Basically, these are the things that will be asked in the interviews. Like, if this is particular 0, 1, 1, 1, how much amount of transfer? Like, if Pstrb value is 0, then what does that mean? If Pstrb value is 0 means the retransfer is being done. Okay, this is about the Pstrb signal. And then coming to P protection signal. Basically, in order to support complex system design, when we are designing a complex circuits, it is always necessary to have protection. Okay, because it is not, as you already know, it is not easy to design the systems. So, since that is not easy to design it, so we should take protection before designing those signals. So, in protocol, in APB protocol, we will be providing this protection by using the P protection signal. Okay, protection unit in APB protocol is P protection, and that is of 3-bit wide. Okay, so based on the width size width, we will be indicating this signal as either normal signal or privilege signal or secure protection level of transaction. We'll be talking about this P protection further in the next sessions while we are talking about the state diagrams and all. Okay, so this is about the P protection signal. So these are the APB signals that you need to understand before uh, going into the further topics in APB, which are state diagrams and the timing diagrams. Please listen to these signals. If you don't understand it, you can ping me in the comment box or in any of my social media handles. I will definitely reply you, and also if you don't understand, I'll make another session completely on this particular signals itself, because signals are very important and these are the basic thing that you need to know before going into the further topics like timing diagrams and state diagrams, right? So this is all for today's session. In the next session, we are going to talk about operation of state diagrams in APP protocol. Okay, so that is all for today. Thank you all.